was covered with dust and showed me this dust that was in his hand, and we didn't know what to do with it, and I thought we were in shock, so we just put it in a bag, and I've been following 9/11 truth closely for a while, and it wasn't until recently I watched a lecture of Dr. Jones's where he said we need more recent dust, so I got a hold of him and we sent him the sample. And I'll also just add that we later had gone down to see what was going on, and we were about 5 blocks north of Building 7 on the west side of the West Side Highway when about 20 minutes before it came down, we were told that they're going to bring it down. And the gentleman about 15-20 feet ahead of me turned around and said they're going to bring it down, and we were all looking at it and completely expecting it, and everybody's around us had our eyes just focused on Building 7 when it did about 20 minutes later just come down. So.
Let me ask you, gentlemen, did you add anything to the dust? Did you sprinkle it with iron spheres? We'll be asked that in court someday, probably. Okay, you hope so, he said. Thank you, Frank and Tom. So, World Trade Center 7 was still standing when the sample was collected. There was no cutting yet of the steel, obviously. It's an uncontaminated sample, just what we've been waiting for, to confirm that this is not due to contamination. It's in the dust. Something happened during the collapse. Now, I announced last April that we saw spheres with aluminum. These peaks represent the elements present in this sphere. Aluminum, sulfur, and iron. Aluminum and iron is a signature for thermite. Remember, it's a reaction between aluminum and iron oxide. And so in the sphere, liquid then, it was liquid at one time, formed a sphere, you see residue from the aluminum and, of course, a lot of iron. And if they add sulfur, then you see that, as you see here. Sulfur makes this molten metal cut through steel faster. It's not required, though. That thermite cutter, as far as we can tell, does not have sulfur added. It doesn't need it. You just blast through with that hot jet of molten iron. I talked about the fact that in thermate, which I designed myself, then to try to match what we saw in the World Trade Center. Let's see, which is which. 15th of March, this is the thermate. I did that after we had observed the content. You see I got pretty close, aluminum, sulfur, iron in both cases. So I can make a thermate easily that matches what we observed in the World Trade Center. Now, it's been 8 months and we've analyzed hundreds of these spheres since then using these state-of-the-art methods. XEDS stands for X-ray Energy Dispersive Spectroscopy. That will be on the exam. XEDS will be on the exam. Okay, I'll make it easier for you. It's a method where we send electrons at the sphere, and X-rays come back, and the X-rays are characteristic of the metal or elements in the sphere. Mostly what we see now, that is, a lot of these spheres show this pattern. A lot of the iron-rich spheres, there's a lot of glassy spheres as well, but the iron-rich spheres often have, in addition to aluminum, see the aluminum peak, the iron peak, silicon, and of course oxygen in large quantities. You expect that because, for instance, aluminum oxide, also the hot iron will react in the air to produce iron oxide. And then potassium. It's very interesting, very characteristic. So I want to clarify or add to now the body of knowledge about these spheres. I haven't seen this published anywhere, but we see a lot of this. Here's some more, just to give you some examples. Put this on the record. Aluminum, same. I've written it out here. FeOc-Galc. Fe is iron, K is potassium, oxygen, aluminum, silicon. FeOc-Galc. Okay. That's what we see, a lot of these. Again, this is the sample 4, and this is the Potter building. Sample 4 is Tom and Frank just spoke at the Brooklyn Bridge. Okay, here's it. Oh, I got this again. Just to remind you, boom, spray comes out. That molten iron spray cuts through metal, forms spheres. Guaranteed. Now, this is new. John Perales, an engineer, purchased thermite commercially. Look, you can buy thermite on eBay. This is not a secret, okay, but you can also buy large quantities commercially. He did. We looked inside. I was puzzling. Where is this silicon coming from in these spheres? Turns out that commercial thermite in the iron oxide, this is mostly iron oxide, but the dark here is mostly silicon. It's silicon rich. And so you have aluminum. Okay, so the top then is the raw thermite, the unreacted thermite, and when you react it, you get these spheres. Something has produced very similar spheres. As we look at it, similar chemical signature, very much the same in the spheres as we find in commercial thermite. Now here's the new discovery, and the question I want to pose today. Could we find unreacted thermite in the World Trade Center dust? We see the residue. This is the smoking gun already, but can we find the gun, I guess you'd say. The unreacted thermite. Ta-da! Many red chips I found in the World Trade Center dust. About last June, I started noticing these. They're attracted by a magnet. A thought came, well, maybe it's just paint. There's all over these little red chips. They're like eggshell chips. You know, you scrunch up an eggshell, and you get about that thickness, roughly speaking. These are quite tough, though. They're strong. And now these are bilayered. This only shows one side, the red side. The other side is a dull gray. Red is the color of iron rust, iron oxide. One of the oxides, Fe2O3. It already suggests something to you. They're attracted by a magnet, suggests iron as well. And now the chemical composition. Are you ready? Of these chips, the red side. I won't talk much about the gray side. It seems to have a high carbon component. It may be a plastic. It's harder to analyze using this method. But the red side has, it's hard to wait to show you. Okay, here it is. These are red chips. The one is from the Liberty apartment, McKinley. The other is from the Brooklyn Bridge sample. These also show, can you see it? It's very clear, iron. It's hard for me to point to it from here, but I think you can pick out now. Fe is iron, Si is silicon, Al is aluminum, K, potassium, very clearly, and of course, oxygen. It's the same signature as the spheres. It's the same signature as the commercial thermite. I put them side by side so that you can look at this. Hopefully, as this is taped, you can pause and make your comparisons. The same signature. Again, the amounts will vary from chip to chip and from sphere to sphere. And where you look on a chip, there are some variations. And certainly where you look on a sphere, there are some, well, from sphere to sphere anyway, there are variations. The spheres typically are small. A micron up to about 1,500 microns. 1.5 millimeters is the largest sphere that we've seen. So here's a comparison now from the Brooklyn Bridge sample, uncontaminated within 20 minutes of the collapse of the North Tower. Again, red chip on this side. Oh, wait a minute, I'm sorry. I've got to correct the title, sorry. The red chip is from the McKinley sample. The sphere, which is here, is from the Brooklyn Bridge sample. And so, but again, you see, from sample to sample, we see the same pattern. Fiat Alci. Okay, now this is from, so I have to look at the title. I remember red dust, I called it back then. When were those data taken? June, yeah, June, you see it this year. This is the first time I've discussed these red chips publicly. I think it's important to get this out. We have done some other tests. I want to mention, so one of the tests I did, so I took one of these red chips and I had a friend scan. It's hard to get thermite to ignite. And I thought, how can we tell if this is thermite or not? It's not easy. It has the right chemical signature. Aluminum, iron, oxygen is what you need. And it's got some other goodies thrown in, silicon and potassium. And so typically, I put the K in parentheses, not all of these show much potassium, but anyway, that's the signature. And so a friend of mine has an oxyacetylene torch with a very fine tip. He uses it for repairing eyeglasses. And so I had him pass it over one of these red chips. It was just 1/32 of an inch on a side, approximately square, and it flamed, it flashed as he passed over it. Now that's not itself a proof, but it's a strong indication, along with the chemical composition and the red color, which indicates iron oxide, that this is a form of thermite.